Hi, I am Sunil Mahabal. I welcome you to the part 8 of the series, How It Works. The series which is based on electrical engineering. The idea is just to make it easy in the simple words. So this is how it goes, part 8. And it mainly focuses on AC 3 phase. So before we start, let us see the chrono electricity. What came first? The first to enter in the field of electricity was battery, which was introduced in 1800 by Alessandro Volta. And we all know that the potential difference between two wires is known as voltage, and it is in the name of Alessandro Volta, just as an honor to him. Then Thomas Edison brought generation. He started DC generation and generating stations he installed. So in commission. So in 1870 he brought DC generation, and in 1893 was the first time in the history of electricity AC came for the lighting, illumination and power supply to the Columbian exhibition, science exhibition. So in that exhibition, first time the AC electricity was used, and it was introduced by Nicholas Tesla. At one point of time, Nicholas Tesla was working in a factory which was owned by Thomas Edison. And when Thomas Edison was working on DC, during that period only, Nicholas Tesla also got the idea of AC. And then he insisted on that and brought in 1893. So why AC became so useful? Because today you see everywhere it is only AC. There is no DC supplying station, thermal power station, nowhere in the world. So why this AC became so useful? The reason is let us see why AC had to be introduced when DC was already there. What was the need to have AC? So DC has many disadvantages. For example, if you have to receive DC supply in your house, then your house has to be within the radius of 2 kilometers of the thermal power station. So that is the limitation. The losses are very high in DC. Transformers which can economically step up or step down voltage cannot work on DC. A transformer cannot work on DC. Now why transmission voltage is kept so high when fraction of it is actually needed by the user? For example, in house we need only 230 volt single phase supply. A industry consuming electricity requires 440 volt three phase. But transmission voltage is as high as 4,40,000, that is 440 kilovolt. So why the transmission voltage has to be so high when we need only 230 volts? The reason is transformer is the device which can step up or step down voltage. The transformer has two windings, primary and secondary. Their relation with each other is as follows. N1 upon N2, where N is the number of turns on primary, number of turns on secondary. So N1 is the number of turns on primary, N2 is number of turns on secondary. So N1 upon N2 is equal to V1 upon V2, voltage here and secondary voltage here. So V1 is primary voltage, V2 is secondary voltage, is equal to I2 upon I1. That is the current drawn by the secondary and current drawn by the primary. So they are inversely proportional. So if we take this equation further, then V1 I1 is equal to V2 I2. V1 I1 is equal to V2 I2. For example, if a industry or a distribution center receives voltage at 11,000 volts or 11 kV and it is drawing 10 ampere current. So 11 kV and 10 ampere current on the primary side. Then let us see what happens on the secondary side, because the product has to be same. Now 10 plus 2, 10 multiplied by 2 is also 20, and 20 multiplied by 1 is also 20. So product has to be same. So 11,000 multiplied by 10 is equal to 440 multiplied by 250 ampere. So the wire which was drawing 10 ampere of current on the primary side can now cater to 250 ampere on the secondary side. So this is the power of transformer, you can say, because the kVA rating of transformer is same on the both the sides, primary as well as secondary. So if you reduce the voltage, the current increases. You can see in this equation, if the voltage reduces from 11,000 to 440 volt, then current increases from 10 ampere to 250 ampere. In short, in a transformer, as the voltage decreases, current increases, and vice versa, as the voltage increases, current decreases. So if you step up the voltage, suppose the generation voltage is 11 kV only. If I talk about Nagpur, then Koradi is the thermal power station. The generation voltage will be 11 kV. Okay. Now you have to step up from 11 kV to 440. So you can imagine that when I increase the current from 11 to 440, then how much the current will reduce? So the current in the secondary will reduce, and at reduced current I will transmit the energy. So what are the advantages? Diameter of the conductor is directly proportional to the current flowing through it. So if the current is low, the size of the conductor will be low. High, the size of the conductor will be big, very big. Hence, transmission voltage is kept very high to minimize the conductor size and to make transmission economical. So if you transmit 440 volts only, which you require in Nagpur, from Koradi to Nagpur, then you will need very, very big size cables, very big. But if you increase the voltage, then the size of the conductor will reduce. So it is purely a economical decision to increase the voltage. Electricity doesn't call for it. You don't need 440 kilovolt in your house for no application. You need 230 volt. You need 1.5 volt to run your transistor. You require 3 volts for mobile to charge your mobile. You require 9 volts for the laptop. So the voltage required is very, very, very low. But the transmission voltage is kept very high in order to reduce the size of the conductor. So because economical reason, it is for the economical reason. So higher voltage means thinner conductor. Now the next question, when single phase was already there, where was the need to have three phase? You see here, if single phase is to be transmitted from one location to other location, then there will be two wires, phase and neutral, and it will suppose transmit power X. Power X means voltage multiplied by current, that is power. So it is transmitting X amount of power. Now suppose there are three phases R, Y, B. Then three wires will deliver or transmit 3x, 3 times the power. And number of wires, how much it has increased? Only 1.5 times the number of wires have increased. Because in single phase, we are requiring 2 wires. And now you are requiring only 3 wires. So the number of wires have increased by 1.5 times only, whereas the power transmission has increased by 3 times. Hence power per kg of conducting material, once again it is a economical reason. For economical reason, there is electrical reason also to go from single phase to three phase, that we will study in the further slide. But here, as far as the transmission is concerned, then three phase is more economical than single phase. Power transmitted per kg will be more in three phase than single phase. Okay. Now next, how the three phase gets generated. We have already seen that when a magnet rotates and there is a conductor, then a sinusoidal waveform gets created. So E2 will be positive half maximum Vm, and E3 will be negative half minus Vm maximum. So at 360 degree it will be completed, one cycle will be completed. And when we say 50 hertz, whatever energy we are receiving, 50 such cycles get completed in 1 second. 50 such cycles get completed in 1 second. Now let us see how the three phase is generated. Now I will introduce two more windings 120 degrees apart. From this R phase, this Y phase is 120 degree apart. And from Y phase, B blue phase is 120 degree apart. And then from B blue phase, R phase is 120 degree apart. So they are 120 degree apart from each other. Now you already know that when pole cross from the area where the R conductor is there, the sinusoidal waveform gets generated. First positive half, then when south pole comes, the negative half. So here if we see, if we introduce two more winding, then one more phase will get generated, but it will be shifted by 120 degree. This is 90 degree and this is 120 degree. And you have one more winding, B phase, then it will further 120 degree it will be shifted and one more sinusoidal waveform will get generated. So when we say three phase, there are three sinusoidal waveforms in the wires. So this is red phase, this is red phase, this is yellow phase, this is blue phase, and this power is ultimately fed to the motor. Okay, so this is how the three phase motor works. Okay, on three wires. But when single phase was there, why was the need to bring three phase? If you see in the single phase, there are 150 times the voltage becomes zero. 150 times. 3 times in one cycle, the voltage will become zero. But if you look at all the three phases together, overlapping each other, then not a single point, there is not a single point on this, on one cycle you can say, that the voltage is zero. Nowhere the voltage is zero. So every time motor will receive some or the other power. So when it comes to power, then you need three phase. With single phase you can go maximum up to 5 HP, but beyond that it cannot deliver the power. So the power gets delivered only when the supply is three phase, because the voltage doesn't become zero any time during the supply. So thank you. We have seen three reasons why AC DC generation started, why AC became so famous, that transformers can work only on AC. Then we have seen that how three phase transmission is more easy. We have also seen how the three phase, why the voltage is kept so high, transmission voltage, though we need very small amount of voltage in house. The transmission voltage is very high because for the economical reasons. It becomes economical to transmit at higher voltage because the conductor size reduces. And in three phase, not a single point of time the voltage becomes zero to the motor, which becomes 150 times becomes zero in single phase. So these are the reasons why AC came to the market and why three phase came to the market. These are the various reasons, and we are running now lakhs and lakhs of motors on AC three phase. Though there are still DC motors are used because for their accuracy and easy control, DC motors are still in use in machines, but mostly it is AC which is available. Thank you very much for watching this video, and if you have liked it, then do press the like button and also subscribe to the channel, because many more videos are going to get uploaded very soon. So have a good time and take care.